Good afternoon, ladies and gentlemen. I'm Zhang Yiqi, come from China USU Petroleum, Beijing. It's my great pleasure to have a speaker to introduce a passage, construction, performance evolution, and enhanced oil recovery regulations of multifunctional compound fracturing fluid system. As we all know, enhanced primary oil recovery of unconventional reservoirs is widely limited by the poor permeability and high viscosity. Although hydraulic fracturing has overcome the problem of low permeability, it still can't solve the problem of poor production capacity caused by high viscosity. And as we know, people often focus on the performance of viscosity, FT, and wettability in the process of second or third EOR, and ignore their impact on EOR in the process of primary fracturing. To solve the problem so far, we do some work. First, we try to construct a multifunctional capacity fracturing fluid system, which can improve the interface characters of high viscosity oil effectively and enhance the recovery fracturing during the primary fracturing process. Then, by controlling the confidence and the concentration of the solution system, we analyze the cooperation mechanism and the influence on the interface performance. Finally, clarify the effects of viscosity reduction effect, wettability, and FT on oil recovery during the POR. Different types and concentrations of viscosity-reducing surfactants have different effects on the emulsifying performance and viscosity-reducing effect of the entire system. So we do our orthogonal experiment firstly. In the result table 1, we can see that the stability of the solution system is positive correlated with the total concentration of the viscosity reducing surfactants. The higher the total concentration, the greater the SV value and the more suitable the emulsion. Besides, we found that SV value and viscosity are positively correlated within a certain range. Is related to the average particle size of the solution system, the degree of dispersion of the particles, and the viscosities of the FT. In the result table 2, we can see that the degree of the correlation with the SV value is descending order is NPES AEO9 Triathlon S100 after analysis is related to the competitive absorption and structure. After the degree of the correlation with the viscosity reduction effect is in descending order is Triathlon X100 NPES AEO9 is related to the synergy and structure. Then we do synergistic effect evolution experiment. It mainly carried out from the viscosity, FT, and wettability. It can be seen from that the left two picture after the addition of alkali. The viscosity and the FT of the emulsion first decreased and then increased with the increase of the alkali amount, and the whole shape showed a V shape. The right two picture shows that the fracturing fluid viscosity and the FT increase with the addition of polymer, and the FT is least affected by the polymer. This is because the special network structure of the polymer. and the surfactant are cross-linked, resulting in an increase in the shear viscosity and a decrease in the adsorption of the surfactant. In the wettability experiment, the results show that the untreated curves are lipophilic. The alkali and phenimers have little effect on the wettability and can only show neutral wetting, while surfactant can cause wetting reservoir on the rock surface. After coupling, it can improve the wettability synergistically and make the rock wettability move towards the hydraulic direction. Finally, we do the enhanced oil recovery performance experiments by a round of half and proof. The result shows in the table and picture. Compared with group 1 and 2, it shows that for the heavy oil, the viscosity reduction rate is not the only target pursued, and the improvement of the recovery rate is limited. When the FT is not in the order of negative quadratic of 10 or not significantly reduced. Compared with group 1 and 3, it shows that if the viscosity is similar, the oil recovery can be greatly improved when the FT decreased across order of magnitude. Compared with group 3, 4, and 5, it shows that for the liquid system of ultra-low FT level and lower FT level, the effect of mobility rate improvement on oil recovery is more important than that of very low FT. The above half and proof experiment evaluates the relationship between recovery and viscosity (IFT), and then we do other experiment to try to evaluate the relationship between recovery and wettability (IFT). Firstly, compared with group 1 and 2, although the IFT of group 1 is nearly an order of magnitude lower than that of group 1, the recovery factor doesn't show a significant improvement. And then compared with group 3 and group 4. Although the IFT of group 4 is higher than that of group 3, the recovery factor is higher. Then, comparing group 5 and 6, the recovery effect of the extremely low IFT is not significant on the whole. With the decrease of IFT, its effect on oil recovery is a weakening trend. When the IFT reaches a lower level 5, the recovery factor can be improved significantly. This is because the change in wettability makes it difficult for the started crude oil to reabsorb on the wall, thereby broadening the range of optimal FT. Until now, the HC5 fracturing fluid system has been applied in more than 10 wells in Chongqing oil field. The construction coverage diagram of field feedback shows that the overall construction pressure is stable and the oil jet pressure is not high, indicating that the drag reduction effect, the sand carrying effect, and the post-pressing effect are ideal. The oil test output of well weight exceeds 30 one day. The oil test output of well B is more than 20 ton one day. Compared with well H, the primary fracturing productive of well C is increased by more than 20%. After our team's work, we draw conclusions that, firstly, in order to improve the primary fracturing production of low permeability and high viscosity reservoirs, a multifunctional composite unconventional viscoelastic fracturing fluid system HC5 was constructed. Secondly, for high viscosity reservoirs to enhance oil recovery, the viscosity reduction rate can't be used as the only evolution index. Thirdly, for low permeability heavy oil, the extraction effect brought by improving the mobility ratio is slightly better than that of extremely low IFT after reaching a lower IFT. Finally, during the fracturing rollback process, the reversal of wettability not only affects the beneficial effect brought about by the reduction of IFT, but also can increase the selection range of optimal IFT from 10 to the power negative 3 to 10 to the power negative 2 level effectively. This is the end of my speech. Thanks for your listening.